Section 1.8 is on the coordinate plane. Now you'll notice again I made a little suggestion that you take notes on this, because this may be something that you'll want to refer to later on when we get into Chapter 8. I know that seems like a long way off. We'll be doing quite a bit of work with the coordinate plane. If you take two number lines, and we've already discussed the number line a little bit, but if you take two number lines and put them perpendicular to one another, as in the diagram, we have what we call the setup for the coordinate plane. Sometimes this is called the Cartesian plane, named after the mathematician Descartes, Rene Descartes, who is the father of coordinate geometry. As you can see on my number lines here, I have positives to the right, negatives to the left, horizontally, and vertically I have positives going upward and negatives going downward. The horizontal axis, this one right here, is sometimes referred to as the x-axis. I'll put a little x next to it to remind me. And the vertical axis is sometimes referred to as the y-axis, because when we are dealing with equations that have two variables, we usually use the variables x and y. But that's a little bit down the line as far as working with equations and variables. Now you can see that the two number lines cross at the 0. This point where they cross, right here, is referred to as the origin, kind of where everything originates. And the two number lines, or axes, one axis, is on the end, with the plural as axes, the two axes divide the coordinate plane, the flat surface that it's sitting on, into four regions. There's one here, and I'm going to use Roman numerals. There's one here, there's a third one here, and another one here. And these are referred to as quadrants. The numbers, the Roman numerals there, refer to quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I'm not 100% sure where the historical nature of the Roman numerals instead of traditional numbers are used, but that's what we're going to use when we refer to the quadrants, or the Roman numerals. Now, here's where it gets interesting. Since there are two axes, any point that is located on the coordinate plane, let's say for example, I have this point right here. That point is determined kind of like when you used to read a road map and you're trying to find a town and it said AE, you would find the letters on one, maybe at the top, and the number, AE, A1, and the numbers on the side, and you could go from the top and the side and kind of reach the middle. So like here, this point I would start on this axis, this is right underneath it, and this axis is directly to the left of it, and I would meet right here. Because there are two different axes that refer to this point, we write an ordered pair. The first part of the ordered pair has to do with the x-axis, the second part of the ordered pair has to do with the y-axis. So for this particular example, that point, the x coordinate is the 2, the y coordinate is the 1, and we write it as the ordered pair 2, 1. The x coordinate going first, the y coordinate going second. The order is very important because the ordered pair 1, 2 would have an x coordinate of 1, a y coordinate of 2, would be up here somewhere. So the ordered pair, and that's what I'm referring to here. The first number is the x coordinate, or abscissa. The second number is the y coordinate, or ordinate. Now what we're going to do is we're going to practice identifying coordinates, the x and y coordinates, or the coordinates, points that are graphed, and then we're going to give you coordinates. We're going to ask for you to graph the points. Okay, what we're going to do is we're going to use the graph that's given, and you can see there are 6 points that are graphed and labeled. Now remember, these points, these are usually emphasized with big dots, and you can see them, and they'll usually use a capital letter to name them. Point A is over here in quadrant 1. Remember, this is the first quadrant, this is the second, the third, and the fourth. To find the coordinates, which is what they're asking for here, of point A, I start at the origin, and I go right, left, until I'm lined up either underneath it or above it, and then I'm going to go upward, downward, until I can get to the point. So here, to get to point A, I'm going to go 3 units to the right. Now I'm directly underneath it. The x coordinate is 3, because I went to the right, it's positive, and then I'm going to go up 2 spots. From the 3 up here 2 spots, then I'll be at this point, so it's 3 to the right, up 2. The ordered pair is 3, negative, positive 2. Almost wrote down negative. Actually, I did write down negative 2. We can do better than that. 3, 2. Point B is over here in the second quadrant. I would start at the origin. I would have to go 2 to the left this time. That's -2, and then up 2 again. It's not always up 2, it just happens for the first couple. So 2 left, up 2 to get to point B. That would be -2, +2. Now point C is on the y-axis. Remember, this is the x-axis, this is the y-axis. So to get directly either above or below it, it means I don't go to the right or left at all. I go 0 units. I start at the origin, I go 0 units. So my x-coordinate is 0, and then I go down 3 spots to get to the C here. So this would be 0, -3. If the x-coordinate is 0, the point is on the y-axis. Point D is over here in quadrant 3. To get to this point, I would go 4 units to the left, and I would be directly above it. Then I would go down 1 spot to get to the point D. So that's 4 to the left, down 1. So that would be -4, -1. Up is positive, down is negative. Right is positive, left is negative. Point E, which is over here in quadrant 4, I would start at the origin, I would go 4 to the right, and then looks like I'm going to go down 2 spots. So that's a +4, -2. Now if you're saying, well, can you tell for sure if you're going to go down 2 spots or is it 2.5 spots? It's kind of tough to tell. Well, that's where graph paper is going to come into play. When you're doing these, you're going to want to use either graph paper or have a grid that's drawn out for you with a bunch of very lightly fainted vertical and horizontal lines so that you can see a more exact value. The last point here is point F, which is on the x-axis here. It's right here, so I would go 2 to the right, but then I wouldn't have to go up or down at all because I'm at that point. So 0 units up or down, so that's 2 to the right, and then 0 units. So that means any point on the x-axis has a y-coordinate of 0. Now I'm going to reverse this. I have some ordered pairs. I'm going to graph them and put the dots down with the letter of the name of the point. I'm going to start with 4, 1. So here I start at the origin. I go 4 to the right, then I go up 1, and I'm right here, and this is point G. Not a very good G there. That's supposed to be a capital letter G. Over here at point H, I have -2, -1, so I start at the origin. I would go 2 to the left, then down 1. You may have done this back in grade school, and after you got done drawing all the points, you connected the dots with lines and probably drew a picture of a turkey right around Thanksgiving time, or something along those lines. Point I is 0, 4. Now, if you remember, if the x-coordinate is 0, it's on the y-axis. So I start at the origin, I go 0 to the right or left, which means I stay right where I'm at, but then I go up 4, and I put a dot here, and this is I. -4, 0 is 0 in the y-coordinate spot, means it's on the x-axis. I would start at the origin, I would go 4 to the left because of the -4, but then 0 up or down means I stay right there, and there's -4, 0. Point K is at -2, +3, so again at the origin, this time 2 to the left, up 3, I'm in the second quadrant here, and this is point K. And the easiest one of the bunch is 0, 0. When you see the ordered pair 0, 0, you know you're talking about the origin. And usually we call it point O for origin, but we'll call it point L here. With a little practice, you can get good at this, and there are many applications, one of which is what we call a scatter plot, which we're going to spend some more time on later. But to get good at this, you need to practice, practice, practice.